All right, so we're going to pick up where we left off. We're just going to practice a couple more graphs, okay? And then the last problem for today will be looking at a picture of a graph and trying to work backwards to figure out what the equation might be, okay? So that's what we have left. So let's go ahead and work through example 4. What is the first thing that we have to do? Factor, yeah. What can we take out here? 3x. What's left?
X minus.
And then how do I factor the denominator? Oh dear.
Oh.
Thank you.
That's my bad.
I just assumed. Okay, so what's left in the denominator? Plus 4, minus 3. Okay, good. Yeah, you guys got to get really good at factoring again if you're struggling with that, because pretty much every problem involves factoring, okay? Nothing cancels out again, so we're already reduced. Before that, though, we should have the domain written down, and you'll see why. What's the domain here? Good. So negative 4 and positive 3 are the values for the domain that we do not include. Once we've done the factoring, the reducing, the domain, now we're just going to find all these details, right? X-intercepts come from where? The numerator, the zeros of the numerator. What's the 0 for 3x? So 0, and what's the 0 here? So those are our two x-intercepts. Y-intercept, well guess what? If x-intercept is 0, automatically y-intercept's going to be 0. Okay, and you can verify that. If you plug 0 in, you get 0 in the numerator divided by negative 12, 0 divided by anything, 0, right? Okay, vertical asymptotes, what are they? Where do they come from?
The denominator.
Yeah, so it's going to be x equals negative 4 and x equals 3. Do we have a horizontal or an oblique asymptote here? Horizontal is correct. Yes? It's the degrees of the numerator and the denominator. If the degrees are the same, that's always a horizontal asymptote. And what would it be in this case, by the way? If the degrees are the same, how do you find the horizontal asymptote? Look at your notes if you forgot. How do we find the horizontal asymptote if the degrees are the same?
Numerator minus denominator coefficient, leading coefficient, or leading term divided
Let's
by.
combine, there we go. Leading coefficient divided by leading coefficient. So what is that? 3 divided by 1. So there's our horizontal. The other time there's a horizontal, David, is if the degree of the denominator is bigger. So let's say this had a degree 3 down here. In that case, it's always y equals 0, whenever the degree of the denominator is bigger. Okay? And so that's all we got. So let's put everything on the graph and let's see what we got. So we have 0, 1, asymptote at x equals 3, and y equals 3. Oh, and there's one thing I forgot to do. Okay? And this is the part that's tricky. Does the graph cross this horizontal asymptote? Okay, remember, vertical asymptotes you don't have to worry about, but horizontal and oblique, sometimes the graph does go through them. So we got to check to see if that happens or not. And so since we know y equals 3 for the horizontal asymptote, we just plug that into y, or in this case r. Does that make sense? And see what happens. So if I set 3 equal to 3x squared minus 3x divided by x squared plus x minus 12. What would I do first to solve for x? Multiply by this denominator, right? So if I take this denominator and multiply it to both sides, obviously on the left I have a 3 I got to distribute to it, right? So that gives us 3x squared plus 3x minus 36. And then on the right-hand side, now my denominator is gone, and it's just 3x squared minus 3x. Okay, do you guys see how we got that so far? Okay, now you see the 3x squareds here? You can subtract those, and those end up canceling out. And now it's just a normal equation with x's. So how do I solve this? So 6x minus 36, or if I move the 36 over, 6x equals 36. So then x would have to be 6. So we got an actual time or a value when it does cross. It doesn't happen all the time, but it does sometimes. So right here, just remember that at 6, 3, that's when it crosses the horizontal asymptote. So you know what? I'm going to go over there and put that point down. This is at 3. So maybe over here is 6, right? Here's 6, 3. Okay? Oh yeah, I haven't done that one yet. Thank you. And so we have the -4 asymptote. Sorry, I drew the horizontal and then I got excited because I knew that that was going to happen. You guys may not have known that yet, but so yeah, don't forget the other asymptote. Thank you. Okay. So look, we're going to use the graphing calculator, but first let's see if we can kind of guess what this thing's going to look like. Okay? We have 2 points here. We have no point in this middle section where it crosses the horizontal, right? So would it make sense that maybe it looks something like this? Maybe, right? On the left side, we have no x-intercepts over here. So this case down here would be impossible, right? Because I would have to cross the x-axis, and I know I don't over there. So that means we have a branch up here. So far we got this one, we got something like this. Then over on this side, I also have no x-intercepts. So I'm going to have to start up here and go right through 6 and probably just kind of hang out right below it. Because it's got to get close to that asymptote when I'm done. Let's see if that's right. Okay, so if you graph it, again, the graphing part is easy. If you got all these details down and you got them correct, you should have no reason to mess up sketching the graph. Let's see. Alpha y equals 3x times x minus 1, x plus 4, x minus 3. Or you could have done the original, but... All right, let's check it out. Zoom standard. Huh. It's exactly what we said was going to happen, isn't it? You guys see that? And now look, this is the kind of cool thing. On the graphing calculator, we actually know there's a horizontal asymptote at 2. Let's put in that asymptote. Oh, was it at 2? It was at 3. I'm like, uh-oh, it's supposed to cross. Thank you. So right around here at 6,3, like I said, that's where it's going to hit that asymptote and then just stay right below it. Does that make sense? Okay. So here's what our graph looks like. We got something like this over here. Here I don't need any points, just a nice little sketch. Here it's kind of like this twisted parabola. It's not a perfect parabola. You see how it's kind of like, what's the right word, warped a little bit towards the right? It kind of looks something like this. Okay? And then on this side, we have a branch up here that goes through 6 and then just kind of hangs out right below that asymptote. Okay? This is probably one of the harder questions, but does this make sense?
Yes.
This is one of them, yeah, because there's a lot of little details here, especially this detail here where we have it crossing 6. What I expect might happen is that some of you might forget to check, and so you would just have this, and then nothing over here just on this part. Okay, and if you have all of that and you forget this little detail, that's still a majority of the points for that question. Okay, this is just a fine detail, but it's one that you need to know. Yes?
So, with
There's no x-intercept. Asymptote is touched. It'd be negative of that, so that's how you can remember. It's going to work backwards. Oblique, if you know how to factor. Okay, that would be, okay, so now before the domain is create a whole, because the domain is 2, okay. Is there a horizontal leading coefficient? Half the horizontal, -1, so no cross. Remember, so we, that right over the redo, I think you guys can do this. And on the left side, you don't have to do it this way. Okay, now if you have maybe this one with the fact, let's see the graph. The table, cruising along, and then when it gets to 2, nothing there. Up and down, right? Something like this. Bad.
It's not an asymptote.
To know. So we one with the horizontal, and we also did the. We always plug 0 in. -1 is one of your. That's okay. No. You can ask questions, but you do not them individually. 5. We have an asymptote. Feel for asymptotes. I haven't talked too much about down, and that means the multiplicity. Now what else? No. So it's x plus. We talked about the vertical.
Give a divide.
This is how type. So really pick. Looks okay. Yes. Now, anytime we have larger, does that make sense? So now we want to check. Okay, first of all, we got of the to get. Okay, that's a good place to stop. You have some time to get some questions answered or work.